Okay, this is a video for the maths workshop we're going to do on Saturday, March 19th. It's grade 12 geometry, and let's get started. Now, you have to read this paragraph up here super careful and make sure you know all of the stuff that's in the paragraph. I'm going to go a little bit quickly here and just say, well, they tell you M's the center, although it's not so important in this one. They tell you that AC and BC are equal lengths, and that's important. They tell you that the angle Q out here is X, and that QP is parallel to AC, and that's important. They tell you that the line AP is a tangent line, and it touches the circle. The tangent touches the circle at point A. So all those things are important, and now let's just get started. Determine given reasons for other angles that equal X. Well, we've got that. We've got that this angle right here is equal to X. This angle here is equal to XQ. Well, A1 must be equal to X, and why is that? Well, because A1 is a corresponding angle with these parallel lines AC and QR. So we say that A1 is X because of corresponding angles AC parallel to QR. That's the first one. Now we know that AC and BC are equal sides, equal length. That means the angles A1 and B must be equal, so B is equal to X. Equal angles opposite equal sides is your reason. Now we've got that one. Well, that angle up in the top of the triangle is equal to the angle between the tangent and the chord. So the Tan Chord Theorem tells us that A2 must be equal to this angle BX here. And one more. That angle there, A2, and this angle P are alternate angles. You can see the Z that's formed there. A2 and P are on alternate sides of the transversal AP that cuts across these parallel lines. It goes to these parallel lines. And so P is equal to X because of alternate angles and because AC is parallel to QP. Well, there's all the angles we're going to use it. The first thing now we're going to prove is that ABPR is a cyclic quadrilateral. Well, we can say it's a cyclic quadrilateral because angle B is equal to angle P. And that is, angles on the same segment force ABPR to be a cyclic quadrilateral. Now we're going to work with this thing right here. We're going to try and prove that BA over BQ is equal to BC over QR. Well, I'm going to put some lines on some of the triangles maybe that we're looking at here. Well, if you're thinking about QR and you're thinking about BQ, well, that means it's this big triangle right here. So we're probably working with that big triangle right there. Oh, in fact, that is the triangle we're working with. And we can see that this parallel line cuts this triangle out, into a small triangle, a big triangle. The parallel line going across there, we can use the proportionality theorem to get some ratios. Because AC is parallel to the base of this triangle QR, we can say that BA over BQ equals BC over BR. So we can make this ratio because of the proportionality theorem. But now that we've got this ratio, hey, do you know what? This BR here, it must be equal to QR. And why? Because these equal angles make these sides equal. So we can say that QR equals BR, QR equals BR because equal sides opposite equal angles. Well, now that QR is equal to BR, we've kind of got our answer because instead of BR, we can substitute in QR and we get the ratio that we were trying to find. The BA over BQ equals BC over QR. And that's your answer. And so I hope that helped.